Okay, so in this video, I just want to look at a couple um, trig relationships and maybe some basic proofs. So some things we should be familiar with are just, the sine, cosine, and tangent relationships in SOHCAHTOA. Um, so here's our right triangle, right, where we have some angle theta. Uh, we have the opposite side, the adjacent side, and the hypotenuse. Um, So one thing right off the bat that we want to point out is the Pythagorean theorem because it shows up everywhere. Most of trig can be broken down into sines, cosines, and the Pythagorean theorem. So just to recap, we know it's uh, square the legs, add them up, and that's equal to hypotenuse squared. Or in this case, if we're using O, A, and H, O squared plus a squared equals h squared. Okay, we're probably used to seeing it a squared plus b squared is equal to c squared, but it's really the same thing. Okay, so let's go ahead with some of the other trig functions. So basically, if we just flip sine, cosine, and tangent upside down, we'll get the other three trig functions. So if we flip sine upside down, we don't get secant, that's a common mistake, we get cosecant. So cosecant of theta is 1 over sine. Okay. Or, and if we think of it as just flipping sine upside down, that's 1 over sine or hypotenuse over opposite. Okay. Cosine, same idea. We flip it, and that gives us secant. Okay, so we flip it, so cosine becomes 1 over cosine of theta. Adjacent over hypotenuse becomes, oops, hypotenuse over adjacent. Okay, so again, we're just flipping it upside down to get our other trig functions here. If we flip tangent, that's an easy one. That becomes cotangent. Okay, and so cotangent, that's 1 over tangent. That's usually not how we'll see it written, or adjacent over opposite. How we'll usually see tangent and cotangent related, and this is because we want to be able to break everything down into sines and cosines, is if we look at tangent, we can think of it as sine of theta over cosine of theta. Okay, and to prove that, we can take sine, opposite over hypotenuse, and we can divide it by cosine, adjacent over hypotenuse. And we know that when we divide fractions, we change this to multiplication and flip. So we get O over H times H over A. Our H's cancel, and we get O over A. So I really like to think of tangent as sine over cosine. I think that is going to help us out a lot later when we're simplifying some trig expressions and maybe proving other trig identities. Okay, and likewise, we just think about these three other trig functions as being flipped upside down. We can do a similar proof for cotangent of theta being cosine over sine. And this one's kind of easy to remember because cotangent, cosine, they both start with co. That might help you remember which one goes on top. Okay, so now that we have those in our pocket, let's go ahead and let's look at some Pythagorean identities. Okay, we're going to go beyond just the a squared plus b squared equals c squared and look at some other ones here. Okay, the first one that we're going to see, and I'm just going to scroll down a little bit, is the one that you're going to use the most often, sine squared plus cosine squared is equal to 1. And to do a quick proof of this, and this might help in understanding it, it didn't just come from nowhere, right? Is we think of sine as opposite over hypotenuse, and we're squaring it. So we square the top and bottom. Plus cosine is adjacent over hypotenuse, so we square the top and bottom. If we add these up, the bottoms are the same, so we get o squared plus a squared over h squared. And by the Pythagorean theorem that we know, o squared plus a squared is equal to h squared. So we have h squared over h squared, which just cancels to 1. And that's our little proof of the first basic Pythagorean identity. It's the most common, it's the one that you are most expected to know, and the other two are good to know, but this one is probably the most important one. Okay, so we'll go ahead, we'll switch colors, we'll take a look at another one here. Okay, so the other one is, here, let's draw a line, break this up a little bit. Okay, so the other one is, tangent squared theta plus 1 is equal to secant squared theta. Okay, and you might see this in another form. You might see this as tangent minus secant squared is equal to -1 or some weird variation. Okay, but this is how I usually see it. So we're going to do the same thing. We're going to rewrite tangent as opposite over adjacent, except we're squaring it. Okay, plus 1. All right, now how can we make this useful? What we can do is we can rewrite the 1 in terms of a squared. So we can rewrite this as o squared over a squared, and we're going to change the 1 to a squared over a squared. Now we have a common denominator. Okay, so we end up with o squared plus a squared on top and a squared on the bottom. Okay, and again, hey, there's the original Pythagorean theorem showing up. O squared plus a squared equals h squared. So let's substitute. We'll substitute in an h squared over a squared. Okay, and we take a quick look back at our original 6 trig functions here, and hey, h over a is secant, so we know this is secant squared theta. There's one more that you're probably expected to know, and that is the one with cotangent. Okay, and I'll actually leave this one to you to go ahead and prove on your own. You can use basically the same method that I used here to prove the cotangent squared plus 1 is equal to cosecant squared theta. So if I were you, I would go ahead and maybe try that on your own. Use the same method I did. I don't think you'll have too much difficulty proving that.